Hey everyone, it's Nadia. Today I will be revealing that an infinite sum adds to a number, or more precisely converges on a number. We will be doing this by determining if this series either converges or diverges. I first want to note that this series is a geometric series. This is simply because the argument of this series is a geometric sequence, so the series itself will also be geometric. So here, I have graphed our sequence that is the argument of the series beforehand. The points on this graph shows our terms or add-ins. So whenever you plug in your first term, you'll end up getting 1/2. Your second term, you'll get 1/4, your third, an 1/8, 1/16 for the fourth, and of course, 1/32 for the fifth. And this can go on for an nth number of terms. So based off this sequence of sums, you are able to find your partial sums. We find partial sums by dropping the first term and then adding the original first two terms to get our second partial sum. And you will continue this for however many partial sums as you would like. So you'll add your first 3 and get 7/8, your first 4 and get 15/16, and your first 5 is 31/32. And I've only done 5 here. Let's note that the numerator is always 1 less than the denominator. This makes it very simple to define very difficult terms such as the 157th term, the 999th term, or even the 31st term. We use partial sums to find what the total amount of sums equates to or converges on. In this partial sum, we can see that these numbers keep getting closer and closer to 1, or in other words, it will be approaching 1. Which also means that the series itself, which is this, converges to 1. And voila, you finished. You can of course accomplish all of this by hand, but where's the magic in that?